Hey guys, Will King here from Hvac Homes. We got some really cool stuff for you today. We're here at a house we built in Tuscumbia, Alabama. It's a custom home here. It's got some really cool HVAC stuff in it. I've got a good friend of mine, Todd Witt, here from Synergy, and we're going to be taking you through all the HVAC design, why the air conditioner system is so important in this house, and how you can make sure your next house is going to be just as well equipped as this one. Well, I think one of the first things I want to talk about is just basically how we're doing things different on our houses and basically what the average homeowner needs to know when it comes to the HVAC design in their own home and why it's so important to get that size correctly. This is Todd Witt from Synergy in Decatur. Todd's been doing Synergy for how long?
7 or 8 years, I guess.
Yeah, it's been awesome for us ever since we got started and got paired up with Synergy. It's made a world of difference in our homes. From an HVAC design standpoint to just overall comfort level, the spray foam insulation that we're doing. But one thing I really want to hit on this morning is basically how we're doing the HVAC design and why that's so important. When I first got involved in construction, one of the common things that we were doing is the whole rule of thumb method when it comes to HVAC design. And basically the guys would say, oh, well, for every 500 square feet in a house, you get 1 ton of air conditioning in it. But clearly that's changed, and with a little bit of time, we figured out that, hey, that's not totally accurate. So we started using y'all, what, a year and a half ago?
Yep.
And you and Josh do the manual J's for us, the manual D's, and I just want to tell everybody what that is exactly. I mean, why that's so important in the house. So you can tell them, what is a manual J report?
Well, I have my HVAC license. We don't do the installation, but we do the actual HVAC design. So what happens is Will brings me a set of plans, typically to begin with. We look over it, we lay out the thermal barrier of the house, and that's the most important thing is figuring out exactly where the insulation is, what we're going to heat and cool. And with spray foam, it just makes it a lot easier. But we draw it out on a computer design program, and we put in the different variables. For example, this house right now, we're facing north, I believe.
Correct. Yeah,
So that's great. Believe it or not, facing north and south on a house is typically the best thing you can do in the south versus facing east or west where you're catching a lot of morning sun in the east, afternoon sun in the west. So we take that into account. We put the different windows in, if the windows are going to have blinds or not. We put what type of insulation. The big thing is bringing the ductwork and the air conditioning inside the conditioned space.
Right.
And that's what we're able to do with the spray foam, and that's what makes all the difference in the world. Maybe later on today we're going to walk out into the attic and take a look around, but what we'll see is right now the attic's about 70 to 75 degrees, where everyone else is around us with standard insulation is 140, 150 degrees, and you're trying to run air conditioning equipment and you're just kind of defeating the purpose. But anyway, we sit down with Will, go over the blueprints, define the thermal envelope, and then we actually put the house design in, and that gives us the load calculation. It tells us how much air conditioning we need and also how much heating we need. But here in Alabama, we're more worried about the cooling and we're more worried about the humidity control.
But I think we can back up to like the 1950s, 60s, 70s. My first house was built in 1950, for instance. All the HVAC equipment was located in the attic, and all the insulation was just blown, I guess at that point, cellulose or fiberglass insulation. Rock wool, actually, I think at that point. On top of the sheetrock. Well, the problem with that is the HVAC equipment was located in an attic that was, like you just said, 130 degrees at best. If you maybe do the radiant barrier in today's time, some of these homes are down to like 120, but still way too hot for a location of HVAC equipment. But things have changed just like any other technology, and that's what I think a lot of people don't realize. We're still building homes today like we built back in the 60s and 70s. Which doesn't make any sense if we were going to use, we don't use iPhones today that we used even 5 years ago. I think building science has evolved greatly in 10, 20 years, especially 30 or 40 years, but yet we still see it's common for HVAC equipment to be located in these hot attics that are ventilated with air that's 130 degrees in the summer.
Yep.
And it's just really declining the unit. So I think what the biggest thing to me, or what I have seen that blows my mind, is how when we get these Manual J reports back from a spray foam house, it's cutting the tonnage almost in half.
Easily.
And that's really amazing when it comes to, I mean, this house that we're in today is 4,200 square feet, and it's one 5-ton unit on the whole house. So I think that's really a neat point to drive home, that it's just the efficiency level of locating it inside that thermal envelope is such a big difference, because you'll see in a little while we're actually talking about spray foam in the roof deck all the way up the decking underneath the shingles, not just on top of the sheetrock. So I think a lot of people don't understand what that means when we just say it in a meeting. I think until they can actually see it, they don't truly understand.
It's just such a big difference. And I grew up manufacturing cellulose. My family had a cellulose plant, so as early as I can remember, I was doing standard type of insulation. Right. And when foam came out, I was like, man, they might have something here. And that's when I dove into getting my air conditioning and figuring this out. And now what we say each other a lot is we want to build our house as tight as possible to the outside with our thermal envelope. And then we want that house, the air inside the house, to be able to move as freely as it can. And that way we're turning the air over and we're dehumidifying. And notice if the word dehumidification keeps coming out, that's what we're fighting in Alabama for comfort. But so many people, I go out right now and someone calls me with their blueprints and says, I need spray foam. Well, I said, have you already got your air condition? Because we do air condition design. They will already have their air condition design put in their house, and they don't even know what type of insulation they're using. Right. And every time I'm like, how many square feet is your house? And they say 3,000 square foot. I divide that by 500. I get 6 tons, and they'll have 6. A lot of times they'll have 7 because they got an extra ton. Yeah. Threw in for safety. And when we do that same load on a 3,000 square foot house, we're usually 2 to 3 tons usually. But one of the big things we've got to understand is when we get that initial load, we're just getting started. Then we're going to come and we get together and we get different prices on different machinery. And I don't know if you want to go down that road right now, explaining to people the difference in variable speed air handlers and multi-speed compressors. Well, what we're doing right now is a lot of people go out and buy, if you went out and bought a car or a truck and spent a lot of money on it, and you got the cheapest motor possible. That's what a lot of these $1 million houses are getting. Right. A lot of the other houses in this neighborhood have the cheapest units you can buy. They have multiple oversized cheap units. So what we try to do is find a very good unit at the best unit, and we'll usually price a good, better, best. And what happens is on these single speed units, it's like buying a car that only has one gear, stop or start. So when you're backing out of your driveway, it goes 40 miles per hour, even though you're only going 20 feet. When you're going down the street to the stop sign, it's all or nothing. So what we're doing is there's a unit that you would think everybody would have, but it's a variable speed air handler. And what the air handler is able to do is slowly ramp up and ramp down. And then not only that, we've got to have a variable speed air handler to make a high efficiency house work. But beyond that, there are variable speed compressors, 2-stage compressors, 5-stage compressors. We want at least a 2-stage compressor. And what that means, especially in a large house like this, when we do the load, we're only figuring out what the worst case scenario is on the hottest day of the year. So in the spring and the fall, nighttime, we're not going to have that load. And a lot of people's houses, that means the unit's not running. Well, if it's not running, it's not dehumidifying, it's not doing the other things it needs to do. So we're able to put a unit, say, in this house, we have a 5-ton. Is this a truly variable speed?
It is,
in this?
Yeah, it's a true variable speed carrier.
So what this does, I believe it starts at 25% of the load. So 25% of 5 tons gives us what? A ton and a quarter. So at night or in the morning when the load is low on this house can run on that low level. We're still moving air, we're still dehumidifying, and believe it or not, it's almost as cheap to start that compressor and have that fan running constantly than it is to stop it, start it, stop it, start it. So with that, it's able to ramp up. So say today's Friday, say they're having a big party tonight and it's going to be 95, 96 degrees today. Say they've got 50 people in their house. Well, this unit's able to ramp up to that top speed, and then when everybody leaves, it's able to ramp down. So it's like having an accelerator on your air conditioning.
And those are communicating units, right? So it actually measures the humidity inside the house and then also outside the home.
Versus outside.
So it can detect humidity levels outside, the temperature outside, and basically decide based off of that, the fresh air intake, when it needs to run, when it don't need to run.
Exactly.
And how much demand is on that unit. Because it doesn't make sense to bring in air when it's 90% humidity out or if it's raining.
And you know what's funny is so many times I hear people say, well, I'm not going with that high-end unit because when it tears up in a few years, I don't want to pay to replace it. Yeah. Who says that in the regular world is that I don't want to buy the best unit because if that motor blows up 20 years from now, I don't want to spend more money. And that's the problem or one of the difficulties we are faced with these units is the ductwork has got to be designed correctly from there. And then one of the big things is we're sitting in this bonus room. And the same thing is true for bedrooms, any rooms that get air fed to them. In this room, if you notice down here in this corner, we have a jumper duct. Right. And as we're trying to feed air into this room, normally if we don't have a path for it to get back to the unit, it's like trying to blow air into a full bottle. We can't get it in here. So that way, what happens is the air inside the main body of the house continues to turn over, but this room doesn't get the cooling it needs and it doesn't get the dehumidification. So one of the simple things we do is we add a return to get this air back out of here. And with foam, used to in bonus rooms, we used fiberglass bats in these slants. Right. We used fiberglass bats underneath, and we used fiberglass bats over the top, and it wasn't insulated well. Well, with this, we've got in itself a little Yeti cooler. Right. And it's super insulated. Then we get the air fed to it, and then we allow the air to get back. So this bonus room, a lot of times you'll go into houses, they'll have two or 3 tons put in a room this size, where this whole upstairs is calling for, I think, 0.8 tons, right, I believe. Right. So it's the cool science that all goes together. And the main thing is, right now, it's in Alabama in a bonus room, it's cool and nice up here and comfortable and dry. It
is. That's you educated me a lot a year ago on jumper ducts. I didn't know anything about them, and now I think I won't build a house without putting jumper ducts in a house. But I know one thing I like to do is just walk through houses as they're being built.
Sure.
Me and you talked about that before in neighborhoods, and everybody has their own flavor they like to do. But one thing I just like to go look and see what they're doing versus what we're doing, and I learn stuff, and then I learn what not to do, all those things. But it's amazing the homes that we're seeing. It's nothing like pulling up to a house that's this size, okay, and you see 4 units sitting outside that house. But guys, I wanted to bring you outside this house for a few minutes to show you the difference that you'll notice on the outside of this big house compared to other big homes that you might see. The first thing I notice when I pull up is that we just got 1 unit sitting here. A lot of houses of this square footage might have 3 to 4 units on one house. So that alone already is standing out to me. Man, this is different. We talked about how we have a nice high-end unit here. This is actually the Carrier Infinity Series 5-ton unit. I think it's 18-seater. And what's neat is that we're standing here having this conversation, and this unit's running.
At 9:45.
It's 9:45, and that's what you said earlier. If you go to most of these houses, basically it wouldn't be on this time of the morning because it's still cool outside.
Exactly.
But this one's on, and you can see the water dripping here. Take a look at the water just pouring out of this condensate drain. It's 9:30 in the morning, and here we are dehumidifying the air, making that house more comfortable. And this unit's probably running right now on very low stage, but we're still getting the dehumidification properties of it. So I just think it's important for people to notice how much water is just pouring out of this house here in Alabama and 90% relative humidity.
And you're going to have that extended out. It's not draining into the foundation, but that you can just see the amount of moisture that's coming out of there. That's dehumidifying that. All these other houses that aren't, it's staying inside, it's getting in the carpet, it's causing the hardwood floors to cup. Big thing in the carpet is dust mites, and what we have is we make a super dry house. We get rid of dust, we get rid of allergies, and then where we're talking about replacing parts in the future, if it ever happens, we have one unit to service versus 3 or 4. We don't have the electrical lines, we don't have the plumbing, we don't have all the stuff that goes with it. So just the quietness of it. If you notice out here in the hall, that's your return duct. That's the duct that brings all the air back to your unit to have it cooled, dehumidified, or heated.
And that's for the whole house.
That's for the whole house, that one big unit, or big. And one of the things that happens in a lot of houses, returns are undersized. So we always want to make sure we have plenty of return. And this is where it gets tricky. If you've ever been in a master bedroom and you have to turn your air condition in your main body of your house down to about 65 to make your bedroom manageable, we're going to show you how to eliminate that problem. And what we've done here is that one of the first things we want to check, if you've ever noticed when your door, when you have your unit running full speed, does your door slam close when your unit's running? And that's that return trying to pull the air back out of here. Well, in most houses, once we close that door, once we close this door, first of all, the air can't get pushed into here. It's like blowing into a full bottle because all the air is here. And everybody says, oh, just undercut your door. Well, you can see how small that undercut is to allow that air back. And what happens is these smarter air conditioning units, they'll actually work harder to try to get this air back, so you're using more energy. And the simple solution is, what do? We put either a return or a jumper duct in each bedroom. And a lot of people don't care to have these extra grills in their house, but really that's the difference of this room getting cool and being comfortable. When you say
jumper duct, though, what do you mean? Like it's not a jumper duct's not supplying any air from the unit. It's not a direct path back to the unit. All you're doing is basically equalizing the two rooms.
I can show you through when we test out houses is we usually close the door, drop a manometer, and we measure and see. But right now, there's no air flowing through that duct. All the air now goes straight into the return. But when we close this door, all it does is take this air from this room back to that return. We started talking about, do we want a house to breathe or not? Well, we want to build the house as tight as we can get it, and then instead of having it pulling air from leaks and crevices that we can't control, the simple thing we do is we put a fresh air vent to the outside of the house to bring needed fresh air from outside. So that is our set of lungs to the outside. So as the air condition exhaust air or occasionally needs air, we're able to bring fresh air from outside into the house. And that happens through running the dryer vent, running the bathroom fans, running different exhausts, the range hood, and it typically has its own fresh air makeup too. But on this, we're able to bring the fresh air in instead of sucking bad air. It comes directly into the unit where we remove the moisture, and it's designed into it. People say, well, how do you know how much air? You can't bring in outside air. You don't want to do that. Why would you bring it in? Because it makes the air fresh, and we provide lungs instead of bringing it in from someplace.
From an air quality standpoint, air exchange inside your house is very important, right?
Exactly.
I mean, if you have sick kids or if you have allergies or whatever, being able to change that air out inside your house is going to make a better air quality and better health for your family. I think it's crucial to have.
It's big. And then we looked downstairs in that master bedroom earlier at that jumper duct. If we closed that bedroom door and we didn't have a jumper duct, that air could not get pulled back to the unit. Well, the return doesn't know it, so all day long it's going to pull outside air into the house. So the big thing is when you start messing with fresh air and ventilation, there's a lot of people who don't want to mess with it
It's the whole
because it's
system.
complicated. If you don't get these jumper ducts and get it balanced correctly, then you are going to have problems. You're going to bring in excess humidity and all kind of other things.
And that's why I think, I mean, again, it drives the point home of why we spend so much time and effort on the front end planning all this stuff and not just showing up on site and saying, oh, okay, well, that's 2,000 square feet, you know, we're going to put a 4-ton unit in it and we're good to go. I mean, it's a lot more to it. And I think the average consumer just needs to understand the work that we put in behind the scenes to make the whole home just super balanced and just an overall very well system. Because any of these components by themselves does nothing. It's truly the whole makeup of this whole system that makes it.
Yeah, and if we don't have a variable speed air handler or a variable speed compressor, this unit would not be running like we just saw outside. It wouldn't be running yet, so all this moisture would be building upside. We wouldn't be turning over the temperatures. We wouldn't be bringing in fresh air. So it's great that one of the things I like to see is that on a cool morning to see my air conditioner running, because we know we're turning that air over and dehumidifying.
And getting it fresh
exactly
that morning. So good deal. Well, I mean, I just think it's important for our customers to know and your customers to know and anybody out there looking to improve their next home, basically the true importance of doing the manual J's that we're doing, the manual D's with you guys, and how just the overall design of a house just really makes a difference in everyday life and in their everyday budget and their overall health. It's just something I want to do to educate our customers, and I think you probably feel the same way with your people.
The biggest investment you will ever have is your house.
Right, and there's no point in basically putting bad equipment in that home that's going to end up costing you more in 5 years.
It was cheap up front, but you paid for it for a lifetime.
Right. Well, Todd, thank you for coming out,
Thank you.
man. I appreciate everything.